Rigging heavy wood. This is where everything comes together. Top removal and rigging heavy wood is one of the most demanding tasks in arboriculture. The forces are higher, the margin for error is smaller, and every decision carries more consequence. At this level, you are not just rigging, you are managing energy at its highest potential. In this podcast, you'll learn how climbers tie into a spar during blocking operations. You'll understand the forces created during top removal. You'll learn how blocking can be combined with speedline techniques. And you'll learn how to minimize dynamic loads when rigging heavy wood below the load. Let's start with tying in. When you are working on a spar, meaning the tree has been stripped of limbs, you no longer have the natural structure of branches for support. This changes everything. Instead of tying into a canopy, you are securing yourself directly to the trunk. This is typically done using a climbing system and a lanyard. The lanyard wraps around the spar and connects back to your harness. It becomes your primary point of stability. As you move up the spar, you reposition your lanyard and climbing line. Your tie-in must always be secure, because when you are blocking down a trunk, you are working directly above the rigging system. Now let's talk about blocking. Blocking is the process of removing sections of the trunk in controlled pieces. These sections are often heavy, and they are often rigged below the cut. This means that dynamic load becomes a major factor. Let's break down what happens during a blocking cut. Before the cut, the piece has potential energy. It is elevated in the tree and held in place by wood fibers. When you make the back cut, that potential energy is released. The piece begins to fall. As it falls, it gains speed. That speed creates kinetic energy. When the rope catches the piece, that kinetic energy is transferred into the system. At the same time, the rope stretches and stores elastic energy. All of these energy transfers combine to create dynamic load. And in blocking operations, those loads can be extremely high. Now let's talk about the biggest risk in top removal. The barber chair. A barber chair occurs when the trunk splits vertically during a cut. Instead of the piece separating cleanly, the wood fibers fail unevenly. This can release energy violently, and it can cause the upper portion of the trunk to kick back toward the climber. This is one of the most dangerous situations in tree work. To reduce this risk, climbers often use a bore cut. A bore cut allows you to establish the hinge before releasing the holding wood. This gives you more control over how the piece separates. The hinge is critical. It controls the direction and timing of the movement. If the hinge fails too early, the piece drops suddenly. If it holds correctly, the piece transitions smoothly into the rigging system. Now let's talk about how the piece is attached. In blocking, butt-hitching is commonly used. The rope is attached near the base of the section, often using a running bowline. Additional control can be added using half hitches or marline hitches. Marling involves adding multiple half hitches along the piece. This helps control rotation and keeps the section aligned during descent. Now let's talk about the rigging system. The load line runs from the piece, through an arborist block, and down to a friction device. That friction device may be a bollard or porta-wrap. The ground crew controls the descent by adjusting friction. More friction slows the load. Less friction allows faster movement. Now let's talk about force. When blocking heavy wood, the forces involved can be several times greater than the weight of the piece. This is due to dynamic loading. The longer the fall, the greater the force. The heavier the piece, the greater the energy. And the more sudden the stop, the greater the load transferred to the system. Moment also plays a role. If the piece is long, or if the rope is attached off-center, the piece may rotate as it falls. That rotation creates additional force. Now let's talk about how to reduce these forces. The first method is reducing piece size. Smaller sections generate less force. The second method is reducing fall distance. The sooner the rope engages, the less energy is created. The third method is increasing friction. A properly set friction device allows the load to be absorbed gradually. The fourth method is using proper cutting techniques. A controlled hinge allows for smooth movement. A bore cut reduces the risk of sudden failure. And careful attention to the back cut ensures a predictable release. Now let's talk about combining blocking with speedline techniques. In some situations, you may not be able to drop pieces directly below the tree. In these cases, a speedline can be used. The piece is rigged using a load line, then connected to a speedline system. As the piece is cut, it is both lowered and moved horizontally. A pull line or tag line can be used to guide the piece. This allows you to remove heavy wood while avoiding obstacles. But it also increases system complexity. Forces must now be managed in multiple directions. The angle of the speedline affects both speed and tension, and the anchors must be strong enough to handle those forces. Now let's walk through a real-world example. You are removing the top of a tree. You secure yourself to the spar using your lanyard. You set your rigging system below the cut. You attach the top using a running bowline and additional hitches for control. You establish your hinge using a bore cut. Then you complete your back cut. The top begins to move. It falls. It accelerates. It builds kinetic energy. The rope catches. The system loads. The friction device engages. The ground crew manages the descent. And the top is lowered safely. Now imagine doing the same operation without proper planning. The piece is too large. The fall distance is too great. The friction is not set correctly. The system is shock loaded. And now you are operating beyond your working load. That is where failure happens. So here are your key takeaways. Blocking and top removal generate some of the highest forces in rigging. Dynamic load is created by movement, not just weight. Proper tie-in and positioning are critical when working on a spar. Cutting technique directly affects how energy is released. And reducing force is about controlling size, distance, friction, and timing. This is the highest level of rigging. It requires awareness, planning, and precision. Because at this level, you are not just removing wood. You are managing energy, controlling force, and making every movement intentional. And that is what separates a skilled arborist from a true professional. You've been listening to the Arborist-podcast. Our goal is to grow our collective knowledge, one domain at a time. If you enjoyed the podcast, please like, share, and subscribe to help us keep this momentum. Until next time, let's keep growing this community together.